Part of a farmer's land is to be enclosed for pasture. Materials limit the perimeter to be 1,000 feet. Letting L represent the length in feet and W the width in feet, write an inequality in which the maximum perimeter is 1,000 feet. Graph the inequality. Note that both length and width are greater than 0. C. Find two combinations of length and width that satisfy the inequality. So for part A, we assume that the region that the farmer will be enclosing for pasture is a rectangular region. So we know that the perimeter of a rectangle is found by taking 2 times the length plus 2 times the width. We are told in the problem the perimeter can be no more than 1,000 feet. Therefore, 2 times the length plus 2 times the width must be less than or equal to 1,000 feet. So there is the inequality that will answer part A. Now we need to graph this linear inequality. So let's come up with 2 points that are on this line. So let's come up with our x and y intercepts, or in this case the L and W intercepts. I'm going to let the x-axis be length and the y-axis be width. So let's find a couple of intercepts here. Let's see what happens when L is 0. And substituting 0 in for L, we get 2W less than or equal to 1,000. Divide both sides by 2. W has to equal 500. And also, if I let W equal 0, that will wipe out this term. 2L is equal to 1,000. Divided by 2. L is equal to 500. So here we have our x-intercept and our y-intercept. The y-intercept is at 0, 500. The x-intercept is at 500, 0. We're going to draw a solid line because of it being a less than or equal to situation. And now I need to determine which way that I'm going to shade. And if we choose our test point 0, 0, it does make our inequality a true statement. 0 plus 0 is 0, and 0 is less than or equal to 1,000. So we will want to shade everything below the line. So everything, including the line, everything under the line also gets shaded. So here are all of my possible solutions that cause this inequality to be a true statement. So part A, we have our inequality. Part B, we have our graph of the inequality. And now part C, they want us to determine or find 2 possible combinations that satisfy the inequality. And here answers will vary. One possible solution would be this point right here, 100, 100. So one possible correct answer, you could let length be 100 and width be 100. Another possible solution, 200, 200, or even 200, 300 would be a possible solution. So those answers will vary.